Alright, here we go. We've got measurement lesson number 4, linear scale factors and perimeter. Earlier in math courses we studied the concept of similar objects which have the same shape but not the same size. One way of describing the enlargement or reduction of an object proportionally is by scale factors. So you may have seen this on things like maps where you have the scale. 1 centimeter equals like 1,000 kilometers. So linear scale factor investigation. Rectangles B, C, and D are all similar to rectangle A, which means they have the same angles. The lengths may be different, but the corresponding angles are all the same. So part 1, measure to the nearest centimeters and then complete the following. First, answer as a reduced fraction, and second, express the reduced fraction to 1 decimal place. So I did the first one for you. The length of rectangle B, 6 centimeters. Okay, and the length of A, 3 centimeters. So then you get 6 over 3, and if you reduce that you get 2 over 1, and the whole number is going to be 2. Let's look at the next one. The length of C, well, it's 4.5 centimeters. You can measure it. So you put that in here, 4.5. And then let's measure A. We already know A is 3, and if we reduce 4.5 over 3, we get 3 over 2, which is a scale factor of 1.5. Next one, the length of D is 1.5 centimeters. And the length of A again is 3. So 1.5 over 3, and if we reduce that, it's 1 over 2, and it's a scale factor of 0.5. Let's look at the next one, the width of B. We're going to get 4. So it's 4. The width of A, we measure. You can get a ruler out, but I'm going to let you know it's 2 centimeters. We reduce that to 2 over 1, which is a scale factor of 2. The width of C is 3 centimeters, and the width of A, again, is 2 centimeters. So we get 3 over 2, which is a scale factor of 1.5. The width of D is going to be 1 centimeter over the width of A is 2 centimeters, so we get a scale factor of 0.5. You'll notice it's the same here as it is here, here as it is here, and here as it is here. So those are scale factors. So use your results for number 1 to complete the following. The length of B is 2 times the length of A, and the width of B is 2 times the width of A. The length of C is 1.5 times the length of A, and the length of C is 1.5 times the width of A. The length of D, you'll notice, is actually smaller than A. The rectangle D is smaller than A, so our scale factor should be less than 1. And you notice that it is, it's 0.5. So 0.5, 0.5 times the width of A. Alright, so linear scale factor. The linear scale factor describes the enlargement or reduction of length. It is described as a ratio in the form A to B, or a rational number A over B, or as a percent. For example, the linear scale factor of rectangle B from rectangle A is 2 to 1, or 2, or 200%, because it was bigger. The scale factor of rectangle C from A is 3 to 2, or 1.5, or 150%. It was also bigger. The linear scale factor of rectangle D from A is 1 to 2, or 0.5, or 50%. So it's 50% as big, it was smaller than it. So a scale factor greater than 1 describes an enlargement, and a scale factor of between 0 and 1 describes a reduction. So investigating the relationship between linear scale factor and perimeter scale factor. So I went ahead and measured the radius here. So this one has a radius of 2 centimeters. Circle B has a radius of 4 centimeters. Circle C has a radius of 3 centimeters. And circle D, oops, I didn't write it in there, that has a radius of 1 centimeter. So if we look at this, measure in your centimeters the radius of each circle, and we did that. Circles B, C, and D are enlargements or reductions of circle A. Determine the linear scale factor in each case. So the linear scale factor from circle B to C is 2. And that's 4 divided by 2. So we had 4 and we divided it by 2. So the scale factor was 2. The linear scale factor of circle C from circle A is 1.5, and that was 3 divided by 2. And the last one, the linear scale factor of circle D from circle A is 0.5, because it's 1 divided by 2. 1 divided by 2 from circle A. The perimeter of a circle is called the circumference, which can be calculated using the formula C equals 2 pi r. Calculate the circumference of each circle as an exact value, as a multiple of pi. First one has been completed. So circumference of circle A is 2 pi, the radius, which was 2. So you get 4 pi. So 2 pi times the radius, which was 2, equals 4 pi. Next one, let's do circle B. Circle B, the circumference equals. So, becomes 2 pi times the radius, which was 4, equals 8 pi. Circle C, circumference equals 2 pi r. 2 pi times 3 equals 6 pi. The last one, circle D, 2 pi times the radius, which was 1, equals 2 pi. So determine the perimeter scale factors by completing the following. The perimeter of scale factor of B from A. So we get B circumference to A circumference is 8 pi over 4 pi, which if you divide you get 2 over 1, which you get 2. The perimeter scale factor of C from A, so we need to take the perimeter of C, which is 6 pi. 6 pi over A, which was 4 pi, equals 3 over 2, which equals 1.5.